Welcome back. Rising sea levels. It's no longer a question of whether it's happening, but just how fast it's happening. And it's not just small island states that we have to worry about. Almost a quarter of the world's population now lives in coastal zones that could be affected. The massive Greenland ice sheet appears to be melting faster than it has before. Antarctica, the world's biggest freezer, is melting too. The sea is getting warmer, and when water heats up, it expands. Thermal expansion accounts for around half of the observed sea level rise in the past century. An international panel on climate change predicts that in a worst-case scenario, sea levels could rise as much as 100 centimeters. That's more than 3 feet by the year 2100. Billions will have to be spent to adapt. Some island nations and low-lying coastal cities could be submerged. Rising sea levels can also contaminate both surface and groundwater, the water we drink. Some environmentalists argue rising sea levels could spark the largest human migration in recorded history. How should humanity fight back or adapt? I'm joined now by John Englander, an oceanographer who specializes on sea level rise. He's also the author of the book High Tide on Main Street, Rising Sea Levels and the Coming Coastal Crisis. John, thanks for joining us.
Thanks, Anand.
I've been looking at the figures, and they're pretty alarming. We have figures of the sea level rising from 1 foot to 6 feet this century alone. How is that calculated?
Well, it's calculated based upon the amount of heat that we put in the atmosphere, the estimated increase of temperature from the global average, and how much of the Greenland ice sheet, the glaciers around the world, and Antarctica will melt, as well as thermal expansion of seawater, as you said. And the challenge to the estimates comes from 2 reasons. One is we're warming faster than in thousands of years, so it's hard exactly to say how heat translates to melting those ice sheets. We've never had that experience in human history.
That brings us to the point, are these figures accurate?
Well, the figures are accurate, but if anything, they're low. The truth is we could have 1 meter, 2 meters, or even 3 meters of sea level rise this century. We don't know because we've never warmed this quickly. And the second thing is we don't know for sure how much heat we're going to put in the atmosphere, because we don't know whether we're going to be burning coal or solar or nuclear or some new energy source over the next 86 years. So we have the double challenge that we're warming faster than at any time in the last thousands of years, and we can't exactly say what our heat input's going to be to the system, how quickly we can melt the ice.
Right, so the main factors would be the melting Greenland ice sheet as well as Antarctica. Are there any other factors that contribute to the oceans rising?
Sure. There's 5 or 6. There's all the glaciers in the world. There's over 170,000 glaciers from the Himalayas and Tibet to Glacier National Park in America to Alaska. But even when all those glaciers melt, we'll get about not quite a meter of sea level rise. But that may take centuries. Greenland's a big problem because it has as much as 7 or 8 meters of sea level rise potential in it if Greenland were to melt entirely. And then Antarctica is the big problem. There's 60 or 70 meters of sea level rise locked up in Antarctica.
Right.
And that will take centuries. And then there's the thermal expansion of seawater, which you mentioned. And the 5th is that land moves up or down a little bit. We call subsidence or uplift. And that either adds to sea level in the case of subsidence, because if the ocean's rising and the land's going down, the effective height increase is greater. Whereas if the land's uplifting, such as in the Arctic and Alaska regions, then it seems to counterbalance sea level rise or go with it. And maybe sea level isn't actually apparent from the landform there.
Right, so what we're saying here is there's a very close connection between the level of the oceans going up and climate change.
Absolutely. Yeah, it's a lag time. The confusing part is that while we're concerned about climate change and we want to do things, use more solar as a lot of countries are doing and decreasing our carbon output, finding ways to deal with that there's a lag time because the heat's already stored in the ocean. We've already elevated the oceans almost a degree Celsius, 0.85 Celsius. And that elevated ocean heat means that even if we stop greenhouse gases today, that sea level will still rise because the ice sheets have to adjust to the warmer temperature. It's kind of like a giant outdoor swimming pool, if you think of it. Even when the temperature goes down, the heat's still in the pool. And we've elevated the ocean heat almost a degree. That means that we will get sea level rise for centuries.
Right, now is it just going to be small island nations that are going to be affected by this, or will all coastal cities and coastal areas be affected?
It's definitely all coastal areas, and it even goes beyond that. It's cities on tidal rivers. Washington, D.C., where we're sitting, is on a tidal river. Sacramento, California, Hartford, Connecticut, and cities all over the world are on tidal rivers. And as long as the river's adjusting with the tides, it means that that land's vulnerable. And of course, the low-lying land like Miami or the Maldives or Bangladesh, where there's vast amounts of low land, are most vulnerable.
You know, we've often heard the example of Bangladesh being mentioned. It has said, the government of Bangladesh has said, we only contribute something like 0.3% of emissions, which is driving climate change, yet we're facing an existential threat. And it's now calling upon, of course, industrialized nations to do something about this. Is that because of the particular geographic characteristics of Bangladesh? I mean, it lies at the apex of a funnel, doesn't it? You've got the Bay of Bengal, which is almost funnel-shaped,
Right.
and then it's on a delta.
That's right. All the delta areas from New Orleans to the Netherlands, and Bangladesh is another one. Any of the major delta areas, Vancouver, Canada has another one. Those are silt lands, which are they're prone to compacting because they were the dirt was deposited by the rivers, and it's pretty loose, and so over time it compacts a little bit, but that adds to sea level rise, and it tends to be land that's difficult to protect. I mean, New York City on granite that rises out of the ocean or the sea or the rivers. It's not a beachfront island. It's actually fairly easy to protect Manhattan. But compared to Miami or Bangladesh, which is low-lying land that is difficult to protect.
Right. A country like Bangladesh also has this added problem in that it gets most of its water is groundwater,
Right.
not from rivers, because all that river water is very salty.
Right.
So they're taking water out of the ground and the ground's sinking. Right.
That's right.
So you've got sinking ground and rising water.
That's right. And the same thing happens where we take petroleum out of the ground. The ground compacts a little bit. Fractions of an inch, but fractions of an inch per year or centimeters mounts up. And we have to realize that while we're dealing with climate change and the energy challenge, that the sea level issue is a lagging response. And so we have to do two things. We need to deal with climate change, but we need to prepare for inevitable higher sea levels. It's a slow problem.
How does one do that? How do we adapt to the fact that these oceans are rising, that land's going to be inundated with water?
It's probably the biggest challenge we face because sea level hasn't been higher than today for 120,000 years. The last time at the similar point in the Ice Age cycle, which is roughly a 100,000 year cycle, was 120,000 years ago when sea level got about 8 meters higher than today. But we have no memory of that, of course. So it's a huge challenge. It's probably the biggest challenge we face because it means every coastal city in the world, it knows no national boundaries, there's no politics in this. The shoreline is moving inland for the first time in 120,000 years, but it's slow. So we can adapt. We can build higher, we can retreat, we can do some innovative architecture and engineering once we realize that this is not something that's going to be fixed by driving solar vehicles or anything like that. We need to do those things, but sea level's here to stay.
You know, I saw a fact somewhere that says that by the turn of the century, this century, fighting the ocean, keeping the ocean back, will be the biggest employer.
Oh, that's interesting. I'd never thought of that. That's probably true, though. When you think about that, the shoreline, again, for 6,000 years, pretty much our whole human civilization has essentially been where it is today. And now we're at this problematic, challenging, or exciting era, depending on how you want to look at it, where the Earth is changing. And even though we may have triggered this change, the fact is we need to begin adapting to a new planet.
How high will it go?
Well, eventually, if we melted all the ice, if we don't do anything to slow the warming, if we allow temperatures to get up 4, 5, or 6 degrees Celsius, eventually we will have 70 or 80 meters of sea level rise. Everything on the coast will be underwater over many centuries. I think the question that more realistically, over the next 50 years, 100 years, 200 years, kind of the foreseeable future, how bad could it get? It could be several meters, and that's going to be a problem.
And what would be the economic impact? Of course, there's an economic impact when you lose land, but there's also an economic impact when you start building levees all over the place.
Well, that's right. I mean, there's as much of an opportunity as there is a threat here, that the people who can get out from the politics and the defensiveness and the denial and say, okay, this is happening. The Earth has changed before. Maybe we've triggered this, but the oceans are measurably warmer. Ice will melt. The shoreline will move inland. People are going to find ways to make money and find new areas to develop, how to relocate some cities, how to elevate some structures. There will be opportunities. But right now, unfortunately, this is so challenging, and people tend to be in denial or turn into a political issue, that many people are frozen in place and not doing anything.
Right, you mentioned political issues, defensiveness, and we know that climate change has its skeptics.
Yes.
Are there skeptics on ocean level rising as well?
Well, there's some people who say this has happened before and man's not having an impact. When I lay out the case of the ice ages are in every geology book. We've known about them for a century. And the ice ages have about 3 kilometers of ice in the northern hemisphere. And as that 10,000 feet, 3,000 meters of ice melts.
Okay, I've got 20 seconds here. Is this getting the attention that it deserves right now?
No, it's just starting. It's just beginning as streets flood with each extreme tide, the king tides. It's beginning to get people's attention.
John Englander, thanks for joining us.
Thank you, Anand.
Okay. And that's it for this edition of The Heat. We would love to hear from you, so please send us your questions, comments, and story ideas to theheat@cctv-america.com. Once again, that's theheat@cctv-america.com. I'm Anand Naidu in Washington, D.C. Thanks for watching.